Okay, we have seen some equations which can give you the trend or relationship between speed, flow and density. And yesterday we said that these equations are not applicable to interrupted flow conditions, because interrupted flow conditions then we have stoppages, and these equations cannot give you zero because of a signal or because of a roundabout. Okay, but the actual flow will be zero, the equation will keep on giving you some numbers. And then we moved on to the case where demand can go above capacity. Okay, and demand goes above capacity, we call it a breakdown. Okay, and the breakdown can happen in one of three situations: whether you have a ramp coming onto the highway, two highways are merging into another highway, or you have an intersection. Okay, we looked at this case yesterday where we have two segments and they are merging into a third one. Okay, so here the demand was equal to volume because volume was less than capacity. Same thing here. To get the demand of this segment, we added these two. So the demand was more than capacity, so volume equals to capacity. Clear? Okay. Moving on, today we will look at the other case of breakdown where demand can go above capacity due to a ramp. Okay, so in this figure you see a highway and then there are ramps connected to the highway. Okay, yesterday we also looked at an example where we calculated the Q and the delay. When there is a breakdown, the important things are Q and delay. Okay, so the horizontal line which you see in the figure is the highway. If you see the top part of the figure, the horizontal line is the highway, and then these are ramps. The inclined lines are ramps. Some of these ramps are coming in and some of these ramps are going out. Some of these are for entering the flow, some of these are for exiting the flow. Which ones are for entry, which ones are for exit? Tell me. The first two ramps are for entry, the last two are for exit. You can see it from the direction of the ramps. Okay, and 1, 2, 3, 4 are not 1, 2, 3, 4, 5 are not the numbers for the ramps. They are numbers for the highway segment. So 1 is the first highway segment before the first ramp. 2 is the second highway segment after the first ramp, and so on. In part A of the figure, the numbers which you see are the demand. Okay, so the first segment has a demand of 2,200. Then we have a ramp. The demand of the ramp is how much? 800. Okay, and the demand of the second ramp is 700. These two are for going in because these are entry ramps. Then the last two, 500 and 400. This is a demand which is going out. Clear? Clear? Now I know the demand of segment 1 and I know the demand on ramps. Using that I can calculate the demand on the other segments, right? So let us do that first. For segment number 2, here, how much is the demand? How did you get 3,000? Yeah, like we did in the previous case, when there are two flows which are combining, you just add them together. Okay, so we have 2,200 plus 800, so that is 3,000. Okay, same thing for we will do the same thing for the next segment. 3,700. You already have 3,000 and then 700 entering. Okay, next one. How did you get 3,200? You have to subtract now because the flow is going out. So we subtracted 500, we got 3,200. Okay, the last one. Now you will subtract how much? 400. Okay, so we have the demand for each segment. In the second figure, you see the capacity of each segment. Second figure gives you the capacity of each segment. Capacity of the ramps are not given. Capacities for the ramps are not given. So we assume that ramps don't have a problem. There is no problem with the ramps. Whatever the demand is, the capacity is enough for it. Okay, clear? Okay, so we are only concerned with the segments of the highway. The segments of the highway, 1, 2, 3, 4, 5. Okay, now look at the bottom figure. The bottom figure is supposed to provide you the volumes. So we have the demand, we have the capacity, now we need the volumes. Okay, some of the volumes are given and some of them we will try to fill it. What about segment number 1? Very easy, right? Because it's given, right? Of the exam could be this way. So 2200, the demand from the first figure. Okay, now segment number 2, we have the demand, we have the capacity. Tell me which number should I put here? Demand is 3000, capacity is 3200. 3000 because demand is less than capacity, no problem. Okay, now we reach this one, segment number 3. Why do I have 3400 here? Tell me.
Because the capacity is less.
Capacity is less, demand is more. So 3400 is what?
Capacity.
Okay. This is what we have done in the previous examples as well. Okay. Now, look at segment number, or look at the ramp. Okay. What was the demand for this ramp? 500, right?
Yes.
But we have 459 here. How did we get 459? How many vehicles are subtracted? Why 49? And you are wrong. It's not 49. And why 49? And why 41 actually? Yeah, why 41? This is what we call as the network effect. Okay. This is called the network effect. Okay, what is the network effect? You had a problem with segment 3. Now this problem is affecting the other ramps and segments. Okay, so this 459 is because of the problem we have in segment 3. What is the problem with segment 3? Demand is more than capacity. And what do we call this phenomena? Breakdown. Okay, so this breakdown will not only affect segment 3, it will affect the other ramps and segments as well. How is it affecting? So the actual demand was 500 here for this ramp. Okay, this 500 is supposed to come out from where? From here, right? 3700. So this 500 is part of 3700. Okay, are you allowing 3700 in this segment? No, we are only allowing 3400. Okay, so the portion of flow you are allowing, that will be the portion of flow which will go to the other segments as well. Not the number, portion. Okay, so how much portion of the actual demand I am allowing here? I am allowing 3400 and the actual demand was 3700. So how much portion is it? 99%. percent of the people are thinking. Like they can think and give me a number. You cannot.
That's 1.89.
Okay? We'll keep it in fractions, no problem. So, from the actual demand, I'm allowing 0.919. Okay? Or 92%, 91.9% of the actual demand. So, this is the demand which will go to this ramp now. So, this 459 is 0.919 of 500. Okay, get it? Okay. So how did I get 2941 then? You already know this one. Now you know this one. Like we did for the demand, we just subtracted. Okay. And how did I get 368? Same. Okay. So this 368 is 0.919 of 1. Clear? Okay, and from this 2941 subtract 368, you get this one. Clear? Clear? Any problems? Okay. Now which segment had the breakdown? Segment 3. We call segment 3 as a bottleneck. Okay. What is the bottleneck? The segment which has a breakdown. The segment where demand is more than capacity. Okay, so that becomes a bottleneck. Okay. Look at segment 1. Volume equals to what? Demand. Segment 2, volume equals to demand. Segment 3, volume equals to capacity. Segment 4, volume equals to demand?
No.
Capacity?
No.
More than that or less?
Yes.
Less. So now we have, up till now what we have seen in all the examples, either volume was equal to demand or volume was equal to capacity. Okay. In this case, now I have a volume which is less than the demand and even less than the capacity. Okay. This phenomena is known as demand starvation. This is called as demand starvation. Volume becomes less than demand and less than capacity. This is called as demand starvation. Okay. Why did this happen? Because of a bottleneck, because of a breakdown. Clear? So after the bottleneck, this happens. After the breakdown, this happens. Okay, you have demand starvation. Okay, which is actually, the flow becomes actually better in the other segment. Okay, so for example, if you are the first one in the line on a signal, the signal is red, the signal becomes green and you are the first one to go, the road is clear for you, right? And nobody in front of you. Okay, so you are cursing yourself, why I am the last one to stop at the signal. Now you feel good, right? That's God's way of balancing things. Okay, which is this one. Clear? So whenever we have a breakdown, after the breakdown, the flow becomes less than demand and less than capacity, meaning the situation on this segment is even better than what you were expecting. Okay. Now we have a problem in segment 3, right? We have a problem in segment 3. I should increase the capacity of segment 3. Okay, let's say I add a lane in segment 3. Now the capacity is more than 4,000. Capacity in segment 3 is more than 4,000. Okay, so for segment 3 no problem, right? What will be the volume in segment 3? 3,700, which is the full demand, right? The full demand. What will be the volume in segment 4 now? What is the demand of segment 4? 3,200. What is the capacity of segment 4? 3,000. Okay, so the volume will be what? 3,000. Huh? So what did segment 4 become now? A bottleneck. Okay, now if you forget about segment 3, if you just look at segment 4 right now, how much is the demand? 3,200. The capacity is 3,000. Okay, so it is supposed to be a bottleneck. Okay, but in the current condition, in this condition, it is hidden. It is supposed to be a bottleneck because its actual demand is more than its capacity. So it is supposed to be a bottleneck, but in the current condition, it is hidden because of segment 3, because of demand starvation. Okay, so we call it a hidden bottleneck. So what is a hidden bottleneck? Where demand is actually more than capacity, but it is facing demand starvation. Clear? Okay. So we learned about 3 things here. We learned about bottleneck. What is a bottleneck? Where breakdown happens, where demand is more than capacity. Okay. What is demand starvation? And demand both. And it happens because of bottleneck. Not because of bottleneck, but because of the breakdown bottleneck.
So, what is network effect? What is network effect?
This is the network effect, right? This is the network effect. The demand starvation is the network effect.
So
Bottleneck created demand starvation in the other segments. So this is the network effect.
So all of this is a network effect.
Yeah. What is happening in these ramps and segments because of segment 3 is the network effect. Okay, so network effect, one of the network effects is the demand starvation. Okay, and demand starvation also did what? It also hit the bottleneck, the next bottleneck. Okay, so a hidden bottleneck has demand more than its capacity, but the actual volume is less than capacity because of demand starvation. Clear? Clear? Any problems? Okay. Okay. Now we are going to start with a new chapter, that is from chapter 9 of the textbook, and that will be about traffic data collection and reduction. Reduction means you have data and you try to summarize it in 1 or 2 values. Reduction doesn't mean, okay, I have 10 values, I will erase 20, I will erase 5 values, it will become reduced. No, reducing means summarize it in 1 or 2 values. Okay, not erasing the values. Okay, what do we need to know when we are looking for collecting traffic data? What are our aims? Okay, so we are mainly dealing with 3 things. We want to know the current state of the system. System meaning the highway network. Okay, what is happening in the highway network right now? Where do I have congestion? Where do I have problems? Which segment is good? Which segment is bad? Which segment has signal? Which segment has roundabout? And so on. Okay, so to know the current state of the system, I collect the data. To know the current demand, the travel behavior, where people are traveling right now. Okay, which highways? Sorry, what is the volume on each highway currently? Each highway and segment currently, the location, the area, and so on. And based upon that, you can do future projections, forecasting, prediction. Okay, so sometimes you see in the news or in the newspaper or even social media posts that we have right now this much population. If after 10 years it will be this much. Okay, so they apply a growth rate, right? That every year it is increasing by this much, so after 10 years it will be this much. How do we get the growth rate? How do I know that the population or the number of cars or the income or whatever inflation is increasing, let's say 2% every year? How do I know? I have to look at the current and the past data. Okay, so from the past and the current data, I see in the previous 2 years it was increasing 2% every year. So next year it will again, I'm assuming that it will do the same. Okay, and so on. So to know these things, we need to collect traffic data. Before you collect traffic data, you must know two things. First of all, why you are collecting traffic data and what you will do with the data. What calculations you will perform with the data. Okay, what is your purpose of collecting the data and what calculation you will perform on the data. Okay, if you go on blindly without this, then you may be wasting your effort and time. Okay, for example, in the term projects, now I told you have to do a trial run, right? Why a trial run right now? Because you don't know what calculations you have to perform or what you will be going to calculate in the end. Okay, so right now you can only do a trial run. Some of the students do that. Usually this used to happen in the mid-semester break. So now they have taken it out. Huh? No more things like this. Huh? So, what happens? People look at the previous projects or they look at the guidelines of the project. Okay, I have to collect data for 1 hour. Then they go there and they collect data. Okay, and then they come back and show it to me, and then I tell them, no, this was not the correct time to collect the data. You should have collected at that time, or you should have collected in this way, and so on. Okay, so that 1 hour is wasted. Okay, obviously I don't care about your time, but in the field, your boss will look for these things. So you cannot say to your client or boss, okay, I collected data last week for 2-3 hours, okay, but I forgot to collect this thing, but I was supposed to do it in this way, but I did it in this way. Now let me go again. It's a waste of time and effort. Okay, so that's why you should know why you are collecting data and what calculations you will perform on the data. Okay, when we say the word traffic, we are talking about traffic data, right? So we said what in the first lecture? We said what? Traffic is made up of what? Vehicles and drivers. Okay, this is the classic purview, the classic concept of traffic. That traffic means vehicles. Okay, but the modern traffic engineers and transportation planners say no. When we say traffic, we mean travelers, and travelers can be in the vehicles or they may be under the vehicle, or they may be outside the vehicle. Huh? Outside the vehicle is who? The pedestrians, the bicyclists. Okay, so all these are part of traffic because all these have traveling needs. Okay, so when you are collecting traffic data, you should consider these other users as well, these other travelers as well. So we call them modes of transportation. So car is a mode of transportation, bus is a mode of transportation. Okay, walking is a mode of transportation. Okay, bicycle is a mode of transportation, and so on, flying as well. So when we are talking about traffic data, it should include all the travelers, all types of modes. Okay. Now, when you say vehicles, then vehicles travel on what?
Road.
Roads and highways, right? So if you say my traffic data is only about vehicles, then the site of data collection is only roads and streets, right? Okay. But when you say I am going to collect traffic data about different modes of transportation, then your space of data collection also is now wider, larger, right? Now, because pedestrians are supposed to move where? Walkways, okay, walkways. So walkways, crosswalks, pedestrian bridges, okay, bicycle lanes, and bus stops, okay. All these are now part of your data collection sites, okay. So the modern purview or the modern concept of traffic data includes all types of users. So you have to collect data about different modes, and you have to collect data from the sites and spaces which are used by these modes, which may not be always streets and highways. Some sources of traffic data, from where we can get traffic data, there are some existing sources. So we have the government departments, they collect traffic data. Okay, they collect traffic data, and many of them, they collect it and then they upload it on their websites, and it is open access, okay, because they know it will be used by so many people. Okay, so for example, in Bahrain, we have 3 ministries which can use traffic data that I know of. There can be others as well, obviously. Okay, you have Ministry of Works, you have Ministry of Transportation, Ministry of Urban Planning, okay. And then you have another department, I don't know whether it's a ministry or not, surveying and land something. So all these departments can use traffic data. Okay, so instead of giving it to them one by one, and then you have the traffic police as well. So instead of giving it the data one by one, you can just upload it and then they can access it. Okay, but obviously the data is about you guys, so they don't upload it. Don't worry. Okay, but there are departments of transportation in US, in Canada, UK, Australia. They upload their data. Okay, so you can access it online. I have given a couple of links here on which you can go and see what type of traffic data is uploaded. The first one is from US, the second one is for the King Fahd Causeway. Okay, so they collect data on daily basis, and I think they upload it every month. Every month they update it. Then we have some devices which are collecting traffic data. So we have GPS in your cell phone, right? Your iPhones and Androids, they have a GPS. So when you open your location, it's being tracked. Okay, when you're using Google Maps, so sometimes you see on the Google Map this route is more congested, this route is less congested. If you go by this route this much time, go by this route this much time. How do they know this? They already, whoever was using their app, they were collecting that. They collect the data, and based upon that data, they say, okay, whoever went to this route at this time, it took him this much, these many minutes. Okay, so if you go by this route now, it will take you 20 minutes. This is based upon data that they are already collecting. Okay, so the congestion levels and travel time which you see is based upon your data, our data. Okay, then we have certain locations where they use electronic toll collection or RFID. So if you go to the Causeway, now they have a system. You can pay through the app, and then you don't have to stop on the booth for paying it. Okay. So in some countries they put a tag on the car. So when the car goes, the tag is scanned, and whatever the text or the bill is, it will go to the driver or the owner directly. Okay. So that is called as RFID tag, radio frequency ID. Okay. You can also scan the registration plate, what the cameras do normally. Okay, so if you have a system in which these tags or these number plates are scanned, then you know from which point the car is coming. Okay, so if you have a scanner at the Saudi side and the Bahrain side, Then you know when the car started from Bahrain and when it reached Saudi. So you can get the travel time, you can get the speed, and you are scanning all the cars which are passing, right? So you know the number as well, you know the volume as well. Actually, you know the volume per minute, or even whenever the car came, it was scanned, right? So you know the volume even for seconds. Okay. So these are some of the available sources. Then we have some devices which you can use for collecting traffic data. Okay. Some of these devices are manual. You have to go to the site and you are collecting traffic data. You can use a device to note down your data. Okay. For example, I will show it here. The first two are the counters. Okay. So instead of writing number of vehicles on a piece of paper, you can use these counters. Okay. So when the car passes, you just click on the button. Okay. And keep on doing it until your data collection is finished and you know the number from the counter. Okay. So we have this hand counter on which you can collect 5 different data items at a time, and then we have board counter as well. You can see it gives you different buttons or different counters in every direction. So if you are collecting data on an intersection, you can have cars coming from different directions. So you can use a board counter there. It will be easier. So a car comes from here, I will put it in this counter. The car comes from the other side, I will put in the other counter. Clear? And then we have counting apps as well. We are using apps for reading Quran or finding out Qibla or finding out prayer times. They have the counters as well for doing zikr and so on. Okay. So these are again simple counters, but this one is for traffic counting. So you can see the sketch of the location as well. So you make the sketch of your location. Okay. And then you can do the counting by clicking the screen. Okay. So these are different types of counters, but all of them are used manually. You will look at the car and click either the button or the screen. There are some devices which you can install on the road and just be free. Okay, so you can install them and go home. Okay, so some of these devices are installed on the side of the road. We call them side fire or radar detectors. Okay, so these are the equipments or devices which are installed on the side of the road, and they will collect traffic data for you. So you install them, leave them, then whenever you need the data, you come and pick them up or transfer the data. Some of them are point detectors. Point detectors are installed under the road, under the pavement. So they detect the car when it passes over them. Okay, but again they are installed and you don't need to go there again and again. Then we can have video based measurements. So you collect a video. Okay, and obviously if you want a good video, then you have to collect it from a point of good visibility. Okay, so we call it a vintage point. Okay, so a vintage point is a point from where you can have a good view of the site. Okay, so you need this. So video data can be collected, and then you can extract the data from the video. How many cars passed, what was their speed, and what was the spacing, and so on. You can get it from the video. Okay, some students do this for the term project as well. No problem. If you have a clear enough video, you can do this. Then we have smartphones and other devices on which the location can be turned on, and then they can record your data. Okay, a few years ago we asked some people to have an app installed and let it record the data, so we can know how much they were walking, what time they were walking, what was the distance they covered there during walking, and so on. Okay, because these devices are collecting the data. Okay, where do we use traffic data? The first thing is for managing the current system. Managing the system means what? When do you need to build a new highway and where? Okay, this is decided based upon demand. Now, how do you know the demand? You have to collect the data, right? Okay. Maintenance activities, management activities. We don't wait till the highway will completely fail, or it will have a 12-hour traffic jam, and then we start designing, or then we start doing something. It doesn't happen like this. Okay? So if you go to the ministry, they will have a plan for next 30-40 years for new projects as well as maintenance and management of the current projects, of the current highways. How do they do that? On the basis of the data. They collect the data, and from the data they forecast where do we need the maintenance and management work. Okay? So you may have seen on some streets the maintenance work has not been done for years. Okay? You have heavy rain or whatever, you see cracks there, you see potholes there, but it's like this. And then you see other highways where you see some maintenance work going on after every 3-4 months or 6 months. Okay? Why do they do that? Based upon data that this street is used by 100 cars in the whole day, and this highway is used by 20,000 people. This one is more important. This one is carrying more load. This one needs more importance, and so on. Establishing time trends and forecasting for future, I already mentioned it at the start. You collect previous data, so you know what is your growth rate, and then you can forecast what it will be after some years. Understanding the travel behavior. Okay, so one person is going from area A to area B. Another person is going between the same areas, but the first one is taking a car, the second one is taking a bus. Okay, same, one person going, origin is same, destination is same, start and ends are same, but their method is different. Okay, so what is their method of traveling, how they are traveling, and why they choose this method? If you don't know these things, your plans can fail. Okay, so you think if I build a new highway at this location, my problem of traffic congestion will be solved. But you don't know what the drivers are thinking, what the travelers are thinking. Okay, so you need to know how and why they are making their choices. Otherwise, you may build a new highway which is not used by anyone. The traffic congestion is the same on other highways as it was. It can happen. So to understand traveler behavior, we need the data. Calibrating the relationship. This is what we did in the last chapter, at the end of the last chapter. We were driving some equations, right? From where did we start the derivation? Anybody remembers?
Speed density.
The speed density, right? So there were some graphs. Okay, and we started making the equations using the graph. So to make the graph, to plot the graph, I need data. Okay, and then some equations were linear, some were parabolic. How do I know which one is linear, which one is parabolic? From the data. I have to look at the data. Okay, clear? So this is called as calibration. Okay, so headway, spacing, we already talked about. There are other parameters as well. We haven't talked about them. Later on, inshallah, we will see. Doing follow-up studies. So you made a change on the highway. Then it is your responsibility to see what are the effects of this change. So you change signal timing on the highway, or you change a roundabout to a signal. What happens after that? So you do data collection to see the after effects of a project, of a change. Okay, so this is called as a follow-up study. To see the effects of the changes which you have already made. Okay. Impacts of new development. Somebody is planning a new mall, 20-story mall. It will have shops and hotel and whatnot. Or somebody is planning a new housing project. It will have like 100 villas, or a building which will have 40 or 50 apartments and so on. So what will be the impact of this development on the road and the environment and on the people? Okay, so again you need the data from similar other projects. So when was the last time a 20-story project was built? Then you go and see what happened at that time. You can expect the same for the new project as well. So to see the impacts, and then evaluating the performance of the facility. Okay, how the facility is performing right now. where we have more traffic jam, where we have less traffic jam, which intersections have more delay, which intersections have less delay, okay, where you can have a traffic jam of 2 hours, where you have where you don't have traffic jam at all, okay. This is part of the performance of the system, performance of the highway network, okay. So to see where we are achieving the target and where we are not achieving the target, okay, where people are suffering and where they are not suffering. So to see that or to know about that, we need the traffic data. Clear?
Yes.
Any questions? Any problems? Okay.